2 screens extended, then you got a resolution invite on both of them to make it work. But is that good?
Good for me.
Alright, can you get the recording started?
Perfect.
Alright, you get it started and I'm gonna go help whoever.
So now you said you go really.
Need
We're gonna start.
Oh, good. Sorry, man.
But we're gonna speak really fast, like we're fast forwarding. Okay, so the people that are supporting Tizen, it's mostly Intel, Samsung, and then smaller groups like Fujitsu, Huawei, Huawei. There's a bunch of carriers that are getting involved now, so there's like backing of a bunch of big companies. And the point of Tizen is that it's all W3C standard. It's not something that they're, I'm not saying everything is W3C standard, so a lot of the stuff they do is W3C standard. So they have HTML5 APIs, they have a bunch of access to W3C, web storage is all W3C, and work policy. So the whole point of Tizen is that they don't want to be like the next smartphone. They do, in some ways, they want like the 50% market share, but they want to be like the ubiquitous solution for smart consumer devices. Anything with the word smartphone, like smart car, smart refrigerators, smart tablets, smart TVs. So that anything that has like a high-end user experience, anything that's like a touchscreen, anything, they want Tizen to be like the thing of choice. And that is supposed to replace Android. Like, we've seen Android on refrigerators and stuff, right? So they want everybody to go to Tizen for this thing. And you can't see this, but this just kind of shows you the anarchy of what the background of Tizen has come from. So we have on the left, like Nokia, Ubuntu, Intel, Samsung, this is all just Tizen related. They forked off and they did like a bunch of touch over here, Sailfish OS, all related to the same, original groups, but they forked off into different products. So in 2010, we have Nokia and Intel doing Migo. Nokia gets rid of that for those Nokia phones that we're seeing now with the newest one. And then in 2011, Intel fails on Migo and says we're going to kind of redo Migo as Tizen. It's this completely new thing and whatever. January 2012, they released like the first open source SDK of Tizen. May 2013, we're on 2.1. July, we're on 2.2. And August, we saw a beta of 3. So it's moving fast now that it's like getting ramped up to some kind of release onto the device. But people are jonesing for some kind of device and they want to see what this looks like. So they've even like photoshopped like Tizen on like these are acrylic. Like it's not a phone. It's just a piece of cardboard that they photoshopped. But like this has made huge news for Tizen. Like everyone passes this around. Like, here's a new phone. It's not. It's just. So this is like the first question we get, like why is Tizen different than any of the other operating systems? Why is Tizen different than iOS, Android, iOS? So there's a bunch of these new mobile platforms that are all HTML5 based. Firefox OS, Ubuntu Touch. So in comparison to Android and iOS, these guys are all web apps, mainly web apps, like that's their primary focus. In terms of native support, Firefox OS does not have any native stuff. I like that I can just point to it. Ubuntu does have native support, Tizen has C and C++, and we do. In terms of the application isolation, in terms of the sandbox model that they're all using, Android has always used Linux UIDs, if you know this. iOS is kind of like in the XLU kernel, they have segregation of the processes. With Firefox, they're kind of Gecko instances. With Ubuntu, it's AppArmor and TBus, making segregation of the apps. And then
we're adding a sandbox.
You're adding sandbox.
There's going to be a sandbox.
Okay.
It's showing what you build in the one
So for now, you have SMAC labels, and we'll talk about what SMAC is. SMAC is not live. We have IDs. Android and Tizen both have Eclipse. Xcode we know about. Firefox still no IDE.
You don't need an IDE. Use a text. It's HTML and CSS3. Come on.
Good luck. Exactly. So the signing model is we've kind of broken them up into the Android model was if it's signed, you can install it on the device, and when you put it up to Google Play, it doesn't like change the signature at all. It's just checking the signature. iOS has like what we call the distributor signature, where you're getting a key from Apple and they're helping you sign the application. Tizen is like a distributor model. We'll talk about this later, but you have to get a specific signing key from the place you're distributing. And notice I'm not saying like Tizen store, because that could be kind of Then Firefox OS is similar to that, right?
Firefox OS is different. So
This is different.
If you're a web app, you need no signing at all.
Right, that's what
if you're a privileged app, you need signing by the developer and by the distributor, because they want to know that you paid for it. And that gives you access to the API and the guide. And
So
if you're a fully trusted app, it means you're signing by Mozilla, yourself, and the distributor.
Exactly. So that's actually the same as the way that we'll talk about that. So there's also this technical steering group that's in charge of all the code. These guys are doing the groundwork and advocacy, working with OEMs. This is just Samsung, Intel, and Huawei. They're the ones that are writing most of the code. And there's contractors that work by proxy. Does anybody here written code for Tizen? Okay, that'd be awesome. So they coordinate all the development. The other thing is that there's this Tizen association on top of everything. They look at the big picture stuff. And it's always 12 companies, but it's always changing. So there's Samsung, Intel, of course, Docomo, Korea Telecom, Orange, all these other Fujitsu guys. These are individuals, there's just 12 of these guys that happen to work for these companies that are keeping track of where Tizen is moving and you know, what changes are happening. So Tizen's claim to fame is that if you score the entire Tizen operating system, everything is a web application, a web app. If you score how they're processing it compared to standards, Tizen is the closest thing to being like the highest score for being most compliant with these other standards. They're better than everything, better than browsers, better than other operating systems. So if that's important to you, you know, Tizen 3 is actually using a higher score than this. So we're blowing away people in terms of HTML5. So, the Tizen application. This is the first step. We'll talk about the Tizen application, we'll talk about the SMAC security controls, and we'll start breaking. This is kind of how the stack works right now. We have two types, web applications and native applications, where they're really unrelated to each other. We have this web runtime environment we'll go through, and we have device APIs, and we have all the HTML5 standard programs, such as W3C stuff. So, kind of three types, web apps, native apps, and a little bit of both. Web apps are all HTML5. They have JavaScript to make the privileged API calls. They can support things like jQuery mobile, all that kind of stuff. They like to highlight that as this is what you should use for all of your apps. They can have package apps and they can have hosted apps. Package is just a self-contained web application that you don't need any additional resources. Hosted is something like I have part of my resources here, but some of the other stuff is on like some external website. Native apps are C, C++, completely unrelated. I can't specify this, like I can't focus on this enough. But these apps, the web APIs and the native APIs have no correlation to each other, and they're always changing. So they'll just be like new APIs all the time. So we can't really do much crossover between like, well, this is how this security model works for a web app, but the security model for a native app is completely different. So we're going to focus on that share. So this WebRT, the web runtime environment, is you can kind of think of it for Android. It's like what Delta VM is. It's a single instance of this WebKit system. It runs all your HTML5 apps. It'll run the application. It segregates apps from each other because it's running in separate processes. And everything that's doing the JavaScript API calls is done through the WebRT environment. This stack looks like this. We have the W3C standard stuff that Tizen kind of re-implemented to customize for themselves. The web app itself, and then the WRT is the instance of the app that gets run. So it's like a Zygo processing in Android. And all of this is based on WebKit and the latest kernel support. So WebKit is completely secure, right? These are a list of vulnerabilities from 2013 of WebKit. They're pretty bad now, right? So we've seen in the past with Android and BlackBerry and iOS that a WebKit vulnerability can be super devastating. For Tizen, this is extra scary just because it's their entire security model. Every application is running as a WebKit instance. So with iOS and with Android, what we've seen in the past, when those got exploited, that was like a browser instance. Now it's like the entire application could be exploited potentially. I'm just saying. I'm afraid. So an app is a widget. It's a web application that they refer to as widget. That's a W3C thing. And it's just a zip archive. It's like Android has APKs, these guys have WG2s. It's just a straight up zip. And inside of this are a whole bunch of files. But go back to the signing stuff. So each application has two signatures. Even if you're practicing and like working with the SDK, you're going to have auto signature, which you generate yourself, and then a distributor signature, which is like a CA that comes with the SDK in this case. But they're working on coming up with a whole bunch of different Tizen stores for carriers, for people on the street. You can just create your own Tizen store. And these are people that have worked with the Tizen Association, are trusted, and have created a store. So I don't know what this is going to look like, but a potential model could be every carrier, every OEM, whatever, has their own Tizen store, and all of the customers will go to that specific store to download the apps they want. So the way that this works is that every one of those stores have a separate signature. So when you want to upload it to the store, you need to sign it with their key as well as your key. So these privileged APIs, these are like, you can kind of think of them as permissions. They're when you want to do anything on the device, you need to make an API. That's all done through JavaScript. And there's three different types. Firefox is two different types. They have like a public and private, or like partner one. They have, for Tizen, they have public, partner, and platform. Public is anybody can access it. If you're a developer, you can access it. So if you want to make a file system call, you want to access external storage, public API. The partner API means that you talk to Tizen and you've told them that you're not a terrible person, or at least prove to them that you want to trick them. And they'll give you partner level permission to access other things like the application manager, which can manage application certificates for the entire device. And then platform are reserved for OEMs, people that are implementing Tizen. This would be carriers, this is like AT Mobile, Como, these give you low-level access like Bluetooth adapter drivers or NFC implementation, all that sort of stuff. So we have a manifest. How many people know Android here? Just I just want to, yeah, I keep referencing that because it's the baseline that we need to compare to, but it's kind of like an Android manifest, or other mobile operating systems have a manifest. But this config XML gets inside of the WGT and it declares, number one, the features, which are granular capabilities. These are the things that your phone or device, whatever you're installing on, looks like. What hardware capabilities it has. Is it front-facing camera? Does it have NFC? Does it even have a radio? Maybe a refrigerator doesn't have a radio, so we can have those. Then they have the privileges. They have the API privileges. These are, I have privileges to access Bluetooth, because I'm calling a specific library. I need to call NFC, and I need to call that. The interesting part of this file is they support this content security policy. So inside here, you can define a whole bunch of content security policies that will be related to MDM in the future, but they're way far away from that. The cool thing that you can do right now with this is define kind of like a cross-origin policy. You can state inside of your app who or what network resources this app should be allowed to use. So you can say, I'm writing this app, it should only be able to connect to Google, it should only be able to connect to DerbyCon. And you can say it's allowed to connect to subdomains, but it's a pretty effective way of whitelisting what network connectivity a single app is able to make. So let's sound like this. This is a terrible example because it's allowing navigation to anything on the internet. So the whole point of whitelisting is hopefully that is set up with like a list of domains or something. Start that. This is a unique ID. When you create an app, the SDK will generate a unique ID for you, and this is how your app is referenced forever in the future. So our app is called Multipass, but it's turned into that unique ID. So you can see above it, it says unique ID.multipass, and now on the file system, that's what you'll see. So here's an example of that. /op/apps, we have just the unique ID. So when you're looking for where is this app located, or where's the data directory of the app, you need to find the unique ID. And this is what the directory folder looks like after you do the install. The bin is just a link to run the WebRT instance to start again. So the AUL launcher will call this specific bin file path. Actually, we have where it's actually just a simple link to the WRT config that's specifically pointing to the multi-path app that we created. And the other stuff we have is a shared directory, data, lists, resources, images. It could be trusted in the sense we haven't seen that used yet, but data, you can just think of it could be a SQLite database. It could be what they call like registry files, which are just like little text files or like a shared craft file. So in Android, we had something called forward locking, and this was like a way of doing kind of like a DRM protection. Tizen has encryption support, and they keep referencing it as DRM support, where you can encrypt in JavaScript, HTML, CSS during install time. It's not like the application itself is encrypted. If anybody gets that widget file, they'll have access to all your files. But when the app gets installed, it gets encrypted using this key on the system, which is usually in /CSA/sec key. If you can access this file, you can decrypt any encrypted app on the device. But without it, you're kind of screwed. We don't know how this encryption works yet because it's not documented, and whatever the source code is, it's really tough to get through. So right now, it's just a key plus the widget equals encryption, so a bunch of math. Or another. So SMAC is this thing that is implementing the entire security model of Tizen. Without SMAC, you'll just have separate processes, and you're hoping that they don't touch each other. SMAC is kind of an alternative to SE Linux or SE Android, if you've seen that stuff. It's a Linux kernel module, and it implements the sandbox model. And they call these things labels. So we'll go through like what a label is in a second, but just think of them as a whole bunch of different rule set that says when one app can talk to another app, and when one app can access a file system object. And with Tizen 2.1, we had 41,000 SMAC rules that do that process. So when one app wanted to talk to another app, what they would do is say, I'm going to look at these 41,000 rule sets, find what's related to my app, and then make a decision on whether or not you should be able to access them. So what SMAC does is it starts doing like control mechanisms for files, for IPC traffic, for network traffic, for process segregation, where if you want to do file control, it'll add these extra attributes, add these extra labels on top of it. So then you can start doing things like A can access B, and this is the type of access they have. So they talk about it like this. Subject is the thing requesting access to the object. The object is the thing, the resource file, the app or a file on the system. The access is just the read, write, execute, delete type permission model. And then the label is just how we refer to it. So it looks like this: subjects, label, and then some kind of access to it. For example, if I have the app /op user apps myid.test, you send that to SMAC64 and converts it into just a label named test app. And then I also have a file that says /temp/file. That gets converted into just my file label. Now I can make a rule that says test app, my file has read access, meaning my test app that I created has read access to my file. Here's some other examples. This is stuff that's on the emulator right now, the contact service. The underscore means you have system level access, meaning anything with an underscore in it will all have the same permissions. So the contact service has system level permissions to do append, read, write, execute, and transmit. The Miracast server, another example, but the worst case scenario is the bottom, where we write an app on contractors.com, we make a policy that says STAR, which is universal access, basically, and we can do append, rewrite, execute on anything of the entire system. It doesn't matter if it's logic, object, or logic object with a SQLite database. So if that doesn't make any sense, this is visualize that. We have the application, the thing that's requesting access. It talks to the security server, which is just a core process, a computer process, communication going on. Requests a cookie. That cookie is dynamically generated and securely generated, hopefully, sent back to the application, which the application uses to talk to a resource. It says, here's my cookie, I'd like to access it. Resource sends that back to the security server and says, this is a cookie of something I would like to access me. What does your SMAC rule set say? And the SMAC rule set will have some kind of rule hopefully for this app, and then make a decision on whether or not we should have access, at which time the resource is delivered to the app, right? So let's do some.
I get to random, some random
So
This section of the talk is just trying to imagine that. Stuff that we didn't have a place to put elsewhere, and we want to deep dive into, but it's probably important to talk about to some degree. So we're just going to kind of skip through pretty quick through these. So one of the things that Tizen has that's kind of cool is a content security framework, and this was a solution that McAfee came up with to address an issue that they noticed in Android, which is you've got these application sandboxes. I'm an application as an antivirus. How do I scan other applications? I can't talk to them. So what they did was they came up with an API for Tizen that antivirus vendors can hook into that gives them low-level access to the system so that they can get around some of the restrictions. The problem with that, obviously, is how do you verify who the antivirus vendor is? And that right now is kind of undocumented. There's like no go through this registration process to gain access to this. So that's kind of like a huge red flag, something to be checking up on as Tizen progresses. It does have a push service. If you guys are familiar at all with GCM or CCD, the Google Cloud messaging, it works pretty much the same way. You've got an app on the device that registers with the Tizen push service server. Tizen push service gives it a registration ID. That then gets passed back to your application backend. If you want to push a message to a device, your app server calls the Tizen server and says, please send something to this registration ID, and then Tizen talks to your phone and sends you that. Where it differs a little bit is messages are limited to text only, and they can only be 1024 bytes. So you can't push like data to these devices. You can, like, literally in the documentation, it's like if you have data, just send a link. So that's the solution to that. ASLR is implemented. It's fully implemented in the Linux kernel. There's some additional stuff that they could implement that's not currently there. So stack protections to prevent buffer overflow checks, and not no execute bit. Someone can review that. Zipper. Good. So Zipper, do you guys know what Zipper is? Have you heard of that? Excellent, good. That's awesome. Zipper is, do you guys know what apt-get is? Yeah, I've seen how it announced that one. That's awesome. It's a package management solution similar to Yum or apt-get. So Zipper is installed, and it talks to a Tizen repository that looks very much like a Debian repository. So you can actually install all kinds of crap on the devices. So like Python, which is a fun one for me. You can just install that on there. The other thing that's cool is the device emulator has OpenSSH running by default, and we've been assured that device emulators look exactly like what a device would look like, so in theory this applies. Again, we have no devices so we don't know what this is going to look like when an OEM gets settled. By default, root login is permitted, and OpenSSH is installed and running, so awesome. So that's it for DevRandom. The next section we're going to talk about is how do we hack these things, and that's some kind of cover the base thing. How do we do assessments against Tizen apps and devices? So the first thing we have to identify is who are we trying to be when we do an app assessment. So there's a couple different scenarios. One is we're a malicious application on the device. Another one is that we're a remote attacker that's maybe compromising the application's backend service. And then, of course, the quintessential I've lost control of my device is the other one that we're looking at. So those kind of break down into a couple different attack vectors. One of them is malicious application stores and third-party stores. Obviously, Android has huge problems with this, not necessarily in the Play market so much, although that usually blows up every couple months. But with third-party stores, definitely there's a huge malware problem going on. So the Tizen model kind of helps out a little bit by having a distributor signing model, similar to how you don't care a whole lot about Apple Store getting compromised very often. It's the same thing, because they have this centralized signing process going on that could help out with some of the third-party issues. The other one is smishing and phishing. Obviously, there's not a whole lot that Tizen can specifically do to fix this. People are going to get text messages on devices, they're going to get emails, and if they retardedly click on stuff, then that's just going to be bad. There's not much you can do to stop that. Drive-by content, like malicious ad networks, which we're starting to see creep up more and more in the Android world. That's going to be helped quite a bit by defining the work access tags and setting content security policies. Obviously, if you have an application that can't talk to remote third-party sites because you whitelisted just your site for communication, it's going to be pretty tough to bypass that with a malicious admin. So, what kind of tools do we have to do application assessments? There's an SDK that's the Eclipse IDE, as we mentioned. There's a web simulator and device simulator that comes with that, and then there's something called STD. So the Tizen IDE, that's pretty straightforward. It looks just like any other Eclipse IDE that you've ever used. It comes, like I said, with the Tizen device simulator and web simulator. The web simulator is pretty sweet. So it runs inside of Chrome unless you run a widget, and it's just like it's Chrome running your web app. But it's got some cool features. Like I highlighted the toolbar that was on the left side of that previous screen. So it's got things like interact with the device. So it's got like an emulator built into the browser. And you can do things like send it fake calls, and you'll get call messages and notifications. You can send push messages, SMSs, orientation changes, geolocation events, and so on. So it's kind of an all-in-one tool to debug in practice your web app. But what this means for a pen tester is, screw trying to do this on the device. Why the hell would I do that? If I'm going to mess with your web app, I can do it inside of my browser, and all my tools that I already have for browser and web-based assessments, I can now leverage against these web-based applications on devices. Where that falls short a little bit, of course, is in like local storage. So if you've got file system stuff that you're looking at, the web-based browser thing is not going to help you too much with that. So then there's a device emulator. It works very similar to the Android emulator. It's essentially the same under the hood. It's QEMU VMs, the disk images are QCal formatted, just like on Android, and it's pretty straightforward. It's got some basic configuration stuff that you can do. So you can change like skin, because that's super critical. You can hardware acceleration. One that's pre-played recently that I haven't played with yet is there's a file sharing option now. And I'm not sure what that does. I know like by default the device emulator doesn't have an SD card. There are SD card images, but there's no way to like inside the, like that's all the options you get. So there's no way to say like where's my SD card, how big is it? So I don't know if like that's an attempt to do that. I need to play with it. I haven't had a chance to do that. And then there's this thing called SDB, which you can see like I just ran SDB, and that's the output. So if you've ever used ADB, this looks really familiar to you. So we call that, yeah, it's not ADB, we swear. And like even to the point where, so I mean, whatever. That's what open source is all about, right? It's embracing the standards.
Change the point.
Right. It's just the point. So that's the good news. And then again, this is just an example using SDB to install a widget onto a device. You can see up at the top, SDB push my widget to temp. And then calling the WRC installer binary on the device and passing it the widget location, and it installs it on the device. So if you've already used ADB, it's really similar. So how do we break these apps? We know what the tools are now. We kind of understand how the Tizen OS looks and what the security model is. These are, if you've ever done any kind of mobile device assessment, these are pretty straightforward steps that you take, right? So you do a static analysis where you're reviewing the code. You do a file system analysis where you're looking at the content of directories on the device and seeing whether things are stored correctly. So we're going to break down each of these a little bit. You do a dynamic analysis where you're opening up the app and manipulating the app, and then network analysis where you're messing around with the traffic that it sends to the backend web server. So kind of breaking those down a little bit to specific things that you look for, which again you look for in Tizen as well, is improper permission requests on a static analysis. So are your applications calling files with and setting them with overly permissive permissions where things like temporary files with everybody can access it and change it? Are your SQLite databases, are they being properly secured? Are you using encryption? If you're storing sensitive data into a database, is it being encrypted? Are you saving static keys if you're doing that? And then cross-origin access, which domains are you allowing? So again, this would be like looking at the config file, the config.xml, and saying, okay, you're allowing this app to talk to everybody, and that's really stupid, so you should probably lock this down to just the things you need to talk to, unless you're a browser, or something like that. File system analysis. So again, it's storing information on the SD card. The way the SD card permissions work is kind of similar to Android. You've got an SD card group, your app requests permission to use the SD card, you can put it into that, or in this case, label. And then everything can access the SD card. So if you're storing your sensitive information on the SD card, are you taking steps to ensure that other applications can't access that? And then, again, file permissions, basically every one of these involves file permission checking. For dynamic analysis, again, with file storage, and the permissive content sharing. So permissive content sharing is a little bit different. What kind of things are you doing to secure your inter-application messaging? So are you, in the Android world, are you got content providers, are you limiting those so that not everybody can access you? Similar things apply in Tizen where you've got receipt communication. Who are you restricting access to? Are you allowing anybody to query you and request all the banking information that you're holding in your database, or are you restricting that to just apps that you manage and will sign? So on. And then network analysis. Network analysis, I think we're all pretty familiar with network analysis probably, but it's the usual stuff: SQL injection, cross-site scripting. How are you handling untrusted server input? Can we blow up your app? Are you using SSL? The difference is the cross-site scripting in this case, because they're all HTML5 apps, and they're using JavaScript to access device APIs to get access to things like storage on the device or address books on the device. Now you've got a situation where cross-site scripting doesn't necessarily mean, oh, I can take your cookie and log into your app. Cross-site scripting means, oh, I've got all the permissions of your app now as an attacker, and if your app has sensitive permissions, my cross-site scripting attack can gain access to users' address books or whatever.
I really want to see the cross-site scripting and group
so that kind of is a different attack vector that we really haven't seen, I don't think, in Android or iOS. So as far as like setting up networking in the middle, how do we do this type of thing? We've got a couple of options right now. There's you can set up a proxy in the Wi-Fi settings, just like you do for an iOS app. Or you can set up IP tables, configuration rules if you've got a root on the device. And then, of course, the tricky part is you got an SSL enabled app. How are you managing that? You add your CA certificate to the Trusted System Store. The awesome thing is that right now there's no way to add a CA to the Trusted System Certificate Store. So if you look, there's like you can view them, and there's a section for user store, but there's no way to get your stuff into that. Fortunately, anything that's in SSL certs that's in PDM format and has 8 hex characters .0 for a file name is a trusted certificate according to Tizen. So the awesome thing is you can take like your example here for where you can take the first CA certificate, read it in OpenSSL, spit it back out of format, push it to the device, and just move it. And I just made it out of .0 because that's not going to flag anything probably. And sure enough, we got added to the Trusted Certificate Store. So that was pretty awesome. So screw you, I don't need to do it. Use the initial attack.
Okay, so a review. We know the applications, HTML5, WRC, or WebRT, WebKit, Google APIs. Talk about SMAC rules and how important they are and how dangerous they are. Right? Like with 41,000 rules, they're really tough to manage. Like, say there's 10 apps on a Tizen phone, that's 41,000 rules. What happens when we get 20 and 30 apps on the phone? It just doesn't scale. So they're working on this, whatever that means. They're talking about changing something called security domains for SMAC, but it's still going to be a ton of rules to manage. So we're going to have to figure out how to do that. We talked about the assessments. We know the IDE, we know the SDK, the emulator. Simulator, the emulator, which is going to be really nice when we want to do just specific web application attacks. And we know network man in the middle stuff, all of that. So, as I've gone through all this stuff, you probably thought to yourself, there's a couple things that sound really terrible, or this is really cool. So, there are no official Tizen devices. There's a Tizen development phone that you can sign up to get. And I heard the Samsung sound earlier. If you have a Samsung S4 or an S4, the newer Samsung devices may have Tizen on them. But if you have an S4, you can flash your system to run Tizen. It's your own custom implementation, so we can't make any conclusions if I rooted my S4 and then I flashed with Tizen and then some exploit was there. It's I'm just exploiting myself. Like I'm the OEM in this case. So you can't really say that there's like some awesome remote exploit possible in all Tizen devices because they don't exist. So we're waiting to see that. So my prediction is a Tizen phone will be released this year, and as soon as somebody that knows what they're doing gets their hands on one of them, it's going to be rooted in like the first change. Not because there's like a major like platform flaw, but because if you see Max Lavell's talk, which is actually right after this one, talking about OEM basic implementations. And that's the biggest concern, especially when it comes to those snack rules that are unmanageable. It's very easy to accidentally say, like this is allowed to access that, and we can exploit that from gaining access to one single application and jumping to the next. Smart devices like cars, TVs, and refrigerators will be pushed by Samsung because Samsung has kind of the market on smart things, right? Like the smart TV is a big product line right now. It would be really easy for them to say, I want to put Tizen on my smart TVs that you guys are already buying. So you're not going to have a choice. It's just like, I'm getting a smart TV, what's this operating system? Just happen to do it. So that's going to be the fastest adoption. Things like refrigerators, that's going to be different. Samsung makes so many things, they can make it like their ubiquitous operating system if they want to. But I think, again, Samsung is going to want to think the whole thing. Smart cars are going to be a little different. Toyota, if you saw that big family lineage thing, Toyota was at the very top of Bada and Migo, and they were getting involved in like these IBI flavors. Tizen has a specific flavor that's already designed for cars, and it wants to be picked up by like Ford and one of the other companies, and it'd be like an in-touch navigation system and in-touch like everything controlled. So it's ready for them to use. The other prediction is that it's WebKit, so you know that exploit is going to eventually come out, and it will be devastating to the Tizen security model. So that's the biggest concern really is intrinsically the use of WebKit in general and relying on WebKit and how many people are attacking WebKit. Not because WebKit is insecure, it's just used by so many people, there are so many people working on breaking it. And then the other thing is that Tizen will probably be adopted, at least their smartphones will be more adopted by non-Americans, just because if you're in a country that doesn't use Android or you're a carrier that's not really pushing Android too much and want to move from kind of like feature phones into something smarter, Tizen is a cheaper alternative, but you don't have to deal with like the overhead of Google. So I want to open it up to like, so I got a question, like how many people have ever used Tizen with the SDK or anything like that? Is there like, yell out if you've ever done it, because I don't think anyone, okay.
I did.
Does anybody want to use Tizen after this, or are they like, we got one, anyone do? So I'll just open it up for any questions or like concerns about the system that you might have. We have a Firefox OS guy too. We can have a dual. I can be only.
What is your?
Yeah, I remember. They changed it like because it's happening so fast. It's 2.1 to 2.2.
Yeah, kernel versions. Yeah, that's 2.4 and 2.1.
That's a 2.1.
Kernel 2.4 to 2.5.
That's 4 months ago. Now they're on 2.2.
They're on 2.2 SDK now, and Tizen 3. So I don't think they jumped to 3. Or 6.6.
Here, like Android, when you prompt it, you just make it like it doesn't.
Yeah, it has the exact same thing where like anything file system equal to. What's that? The security for.
No one cares, but like if you're a technical person, you would know that okay, this is that, but not
I don't know what an FC is. Yeah, sure, you have access to that. But it's the same model. Oh, you got a couple of
I pick an Android app.
Okay.
Do you foresee any serious problems from the disconnect between the native app and the web app side that you mentioned? Because that looks like a giant red flag to me.
Yeah, it's a huge gap between those two, and Tizen is really downplaying the native app and trying really hard to say Only usage if you're going to be doing games or other graphics heavy stuff where you need to access like hardware accelerated GLs type stuff. Anything else go through HTML5 if you can. And I think it's probably fair because I expect probably the initial ramp up is going to be people porting like HTML5 iOS apps to Tizen because they've already got the code. Most of them.
Yeah. Sorry, one more thing. They have like a migration model from 2.1 to 2.2 because they changed it so dramatically. They had to show developers how to change the code again to make it work. So like they're not even like caring about anything else. Yeah,
Sasha, what's it for the cloud model as far as like where your contacts go and everything else? Can you hear me or not? So for the cloud model for Tizen, who's going to host like the contact list and everything else that's on your phone today goes somewhere, right? Out in the cloud? Do they have like a model?
Like store your cloud backups of your contact list?
Yeah.
I haven't looked into that to be honest with you.
Well, everything's like Android where it's just like kind of, it's going to be the same as the distributor console. You can have like multiple Play stores, you can have multiple cloud providers.
Okay.
I don't think Tizen doesn't actually exist.
Right.